Hello, I've not done this a lot recently, but I'm going back to the Nerdle puzzles, so let's see how we get on with the full set today, and that's a really good start. So it could be 90 something minus 20 something equals 73, just swapping around the 2 and the 7. And then what are we going to do to fill in the blanks? 4 minus 1 equals 3, so let's go with that. Oh, everything was correct apart from the last thing I did. So it could still be 3 and 0 or 6 and 3. I think it's just a 50-50 at this stage, so let's try this. And it was 3 and 0. So actually that's 4 guesses, and I almost got that in 2, so that's a little bit disappointing. But nevertheless, we didn't get stuck for too long, so we continue. And we'll go on to the binodal, and the equals are in the different place. So the top one is going to be a 3-digit or a 1-digit result, whereas the bottom is a 2-digit result, which makes it a little bit more awkward potentially, because if I'm trying to guess one, I'm not going to be getting quite so much information about the other. Let's go with addition. Yeah, let's go with some addition and see if that works. I'm going to have to use some duplicated digits, which I don't like doing, but it will give us some information. Oh, it was 24. So that's not a bad start, but what's going to come next? The 8 isn't going to be here. Or it could be something 4 and something 8. And then we just need to work out what the other 2 digits are, so we can only use 1, 2, 4 and 8. So this can't be 4, because we'd need a 6. It could be a 2 and a 4. Yeah, because it can't be a 1. I think that might have to be correct. Lots of duplicated digits then, which means that we really haven't been given any information on the top one. So the top has got a 3, 6, 7 and 9 and possibly a 1. And it's either multiplication or division. That might make things difficult. I mean, it could be a 7 times something ending in 9. I don't know if that specific sum works. What would it have to be? That would be 483, I think. What if it was 67 times 9 instead? That would be 603. So it's really close, but we've ruled out the 0, unfortunately. I'm thinking that the 7 and the 9 are the last 2 digits, so that we can get the 3 over here. Or we could be 77. I think that's 693. Let's try that. Oh, so close. So it's actually 7 times 99. That's very interesting, but it's the same result, but just a different sum. 7 times 9 times 11 is the prime factorisation, and the 11 was multiplied by the 9 instead of the 7, if you see what I mean. But we got there in the end. Well, not the easiest, I don't think. This one's going to be 6 minus 18 over 9, so this is a nice easy one. 7 seconds, yeah. Never disappointed with a 7-seconder in this context. Right, we've got some addition here, so let's try 58 plus 21. Yeah, that uses all new digits. Oh, and we've got most of the digits now, just 1 digit missing, and then we just need to rearrange them. We've got nothing in the right place. So I'm thinking 70 something plus 1 and put the 9 there. So we could have the 5 and the 8 to make something ending in 3. Oh wow, we've got everything just in the wrong order. So I'm going to swap, oh no, I was going to swap the 1 and the 7, but the 9 is wrong. So actually, if this is not 9 or 7, it has to be 5. And that has to be 3 and 1, I think. So that means we've got a 9 left, an 8 and a 7. Yes, that works. It's interesting how I got most of the digits just in completely the wrong positions. That's why maths is so fascinating, because it's very commutative. I don't even know if that's the right word for what I meant to say, but you know what I mean. Let's move swiftly on. What should we try today? Let's try 5 plus 7. Okay. Let's try 15 minus 9 then. Oh, okay. So the 9 can't be here, because then we wouldn't get down to single digits. So the 9 has to be there, so the 5 has to be there. So that means it has to be 14 minus 5. There we go. And the mini binode, or what are we going to do today? I'm going to go for 3 times 7. Let's try something that's not just 12 over 4. Although, as I'm saying that, I've noticed I've used 1, 2 and 3 anyway, so that's most of the same digits. And actually the top one could well be 12 over 4 equals 3, or 12 over 3 equals 4. If it is, I'll be very annoyed I didn't start with it. Okay, it's not quite, so it's going to be 12 minus 9. And what have we got on the bottom? Oh, we've ruled out lots of digits, but we've not ruled in many digits. Could be 6 times 5 or 5 times 6, and there's probably other options. 6 times 6, for example. But I was never going to guess that as my 4th guess, because it was way too many duplicated 6s. But we did get there eventually. And so finally we'll move on to the micro. What do I want to do today? Let's try 7 minus 5, why not? Right, so if it's not minus, could be times or plus, couldn't it? Let's try 3 plus 5. Right, so it's going to have to be, sorry, times or divide. Could be 5 over 5, or it could be 1 times 5. I think those might be the only 2 options left. I suppose it could be 0 times 5, but that feels unlikely. So it was 1 times 5. So that's the full set of Nerdle puzzles for today. Let me know how you got on. Thank you for watching, and bye for today.